All right, let's talk about the expected value. The expected value is sort of like a weighted probability. Remember, in weighted means we took our data point times a weight, so maybe by the credit hours that you were taking for a GPA. This time we're going to take our probability times a weight. And for most of our examples, our weights are going to be money. So the probability of winning something times that something, plus the probability of winning something else times that something else. And we would add up all these different weights. Since most of the time we're dealing with games, we do have something that's called a fair game. A fair game is basically when our expected value is 0. That means that the game isn't in favor of the player or the person who made up the game. If we have a negative expected value, then the game is in favor of the person who made it up, in favor of the house, most of the time we say. And that means it's against the player. If you have a positive expected value, then that means it's in favor of the player and against the house. Let's take a look at a simple game. So we're playing a game with a die. If you roll an even number, you win $5. If you roll an odd number, you win nothing. So we know what the expected value is. So I have my probability, 3/6 of an even number. Remember, if you roll an even number, you win $5. The probability of an even number is 3 out of 6 on the die, times $5. Probability times weight, plus the probability of an odd number is 3/6 as well. And that weight is $0 because you would win nothing. So 3/6 times 5 plus 3/6 times 0. Now our probabilities don't always have to be the same. In this case they are. So 3/6 times 5 gives me 15/6. 3/6 times 0 gives me 0. And 15/6 reduces down to $2.50. If we're talking about money, then we're going to want our expected value written out like we see money. We don't see money as fractions. We see it as a whole number and then 2 decimal places. Now, same problem, but what if we charged $3 to play the game? So we're adding a little bit to it. Anytime we're told how much a game costs to play, we still find the expected value like we did already. So we find the expected value of $2.50 minus the cost every time. Expected value minus cost. So that's going to give me negative 50 cents. One more question with this problem. So the same scenario. But now I want to know, what would we need to charge to make the game fair? Well, the game is fair when the expected value at the very end ends up being 0. So in the last example, I did expected value minus cost, and I got negative 50 cents. I would need for the expected value minus the cost to be 0 to make the game fair. So I'm always going to charge $2.50. You basically charge what the expected value is to make a game fair. Another way to say that is a game is fair if you charge what the expected value is. Let's take a look at another example. We're going to play another die game, but this time, whatever number you roll, that's how much money you win. So for instance, if you roll a 4, you win $4. If you roll a 2, you win $2. I'm going to ask the question, how much should be charged to make the game fair? Anytime I'm asked how much should I be charged to make the game fair, that's just saying find the expected value because they're one and the same. So I can roll a 1, which means I would win $1 times 1/6 the probability. Plus winning $2, the probability of winning $2 is 1/6 because to win $2, you have to roll a 2. Basically, all our probabilities in this problem are going to be 1/6 because you have a 1/6 chance of rolling each number. And then I have every possible number for my money. So this is rolling a 1, 1 times 1/6. 2 times 1/6 is rolling a 2. 3 times 1/6 is rolling a 3. 4 times 1/6 is rolling a 4, etc. Multiplying these, I'm going to get 1/6 plus 2/6 plus 3/6 plus 4/6 plus 5/6 plus 6/6. I didn't reduce these down because in order to add fractions, I need a common denominator. Whenever I add fractions, I keep the denominator the same, so 6, and I add across the numerators to give me 21/6. And that reduces down to $3.50. So that's how much I would want to charge to make the game fair.